This one's tech active, so we can use our calculators. A rowing crew of 4 rowers is to be selected in order from the first seat to the 4th seat from 8 candidates. Now, as soon as they're telling me in order, they're telling me order matters. So I've got a permutation. So determine how many different arrangements are possible if A, there are no restrictions. So for no restrictions, I've got that N is 8 and R is going to be 4. And so my NPR will be N factorial over N minus R factorial. And we have 8 factorial over 4 factorial. And using our GDC, that's 1680 arrangements. All right, now, the second one says Jason or Chris must row in the first seat. All right, so that means I've got a choice of 2 people to row in my first seat, and then seat 2, 3, or 4 can come from the rest. So we could have our number of, and you can do it either way, a number of arrangements. And we've got our 4 seats. So I've got a choice of 2 people for the first seat. Now there's nowhere that says that the Jason or Chris can't row in the others. So that means there's 7, 6, 5, and that's going to be 406. We could also write it as number of arrangements is going to be 2 select 1 multiplied by 7 selecting 3, and that's going to be 420 ways. Okay, now Jason must be in the crew, but he can row anywhere. Okay, so we have to select Jason. So doesn't matter where he's sitting, but we have to select him. So we have a number of arrangements. And we have to select him. But he can sit in 4 seats, in any of the 4 seats. And then the other 3 people have to come from the rest of them. Okay. You might want to make a note. Have to have Jason. He can sit in any 4 seats. And this is our remaining. Okay. And that's going to be 1 times 4 times 7 factorial over 4 factorial, n minus r, and that's 840 different ways. Okay, now if Jason is not in the crew, well, now I've only got 7 people I can choose from and all 4 seats. So my number of arrangements is going to be 7 choose 4, and that will be 7 factorial over 3 factorial, which is 840 different ways.